Moving on to question 2. Data relating to the lifetimes, to the nearest hour, of a random sample of 200 light bulbs from the production line of a manufacturer was summarized in a grouped frequency table. The midpoint of each class in the table was represented by X, and the corresponding frequency for that class by F. The data were then coded using the equation shown and summarized as follows. Calculate estimates of the mean and the standard deviation of the lifetimes of this sample of bulbs. Okay, so data's been coded and we're going to need to uncode it. So these are the coded values and we're trying to get back to find out what X was. First, we need to finish some of these calculations. So let's go ahead and finish what is the mean for Y and what is the standard deviation for Y. So Y bar is going to equal the sum of Fy divided by the sum of F. Negative 467 divided by 200. And that leads to an answer of negative 2.335. Okay, similarly, I should be able to find the standard deviation for Y. We know that first we need to find Y bar, and then we find the S of YY. And then after that, we can find the sample standard deviation. All right, let's substitute those values in. Sum of Fy squared, nicely we've been given. This is our 200. And we have the that leads us to an answer of 8,088.555. And when we substitute that into here, so that answer divided by 199. Okay, so that leads to a sample standard deviation of 6.3754. We'll take 4 decimal places for non-terminating decimals. Okay, so these are the statistics that we have for Y. I'm going to write this as standard deviation for Y. How can we turn that into the values that we need for X? Remember with coding, addition and subtraction are going to affect the mean. Multiplying and dividing are going to affect the mean. The only thing that would affect the standard deviation is the multiplying and dividing. So to find X bar, we're going to need to undo the coding that was used here. Okay, so according to the coding, Y bar equals X bar minus 755, all divided by 2.5. Rearrange this to make X bar the subject, and I'm going to get X bar. So X bar is going to equal 2.5 Y bar plus 755. Okay, so just substitute in the value that we had. Negative 2.335. Add on the 755 and just plugging that into the calculator gets us our answer of 749.1625. Okay, so we've uncoded Y bar and we found X bar. Let's think about what the coding formula for standard deviation of Y was. So to find the standard deviation of Y, we know that only the multiplying and dividing would have had any impact, so we're going to ignore the subtraction. So I know that would be the standard deviation of X divided by 2.5. Simple rearrangement here, making standard deviation of X the subject, 2.5 standard deviation Y. Plugging in that value for standard deviation of Y. .3754, and that equals 15.9385. This terminated at 4 decimal places, and that's my uncoded values for X bar and standard deviation of X. So, firstly, I used the summary statistics to calculate y bar and standard deviation of y. Then I looked at the coding formula and decided whether I needed to use it in its entirety for the mean, or if I only needed to use the multiplying and dividing, which was for the standard deviation. So these two values and the calculations to get here will be worth all of your marks.